Okay, so let's start by talking about problem 8, which is find the number of two-digit positive integers whose digits total 7. Would anyone like to talk about how they solved this question? Bella, would you like to share your thoughts? I don't know. Okay. Did anyone solve this question? Raise your hand if you solved your question, or feel free to type into the chat if you solved this question. Did anyone solve this question? Okay, someone solved it. Jasper says, I'm not sure it's right, but I got 7. Well, let's find out, I guess. I mean, this question honestly is really simple, right? Because all you do is count, right? The number of two-digit positive integers whose digit totals 7. Since it's a two-digit positive, exactly, Jasper. Yep, you just count like 0 and 7. Exactly. Well, I mean, I will say though, because it's a two-digit positive integer, sorry, since it is a two-digit positive integer, the first digit can't be 0, right? Because 0, 7 is just 7, and that's a one-digit integer. So the first digit has to be 1 or above. But in that case, you can just count, right? Because if it's 1, you can only have the other one be 6, right? Because that's the total 7. If it's 2, the other one has to be 5. If it's 3, the other one has to be 4. If it's 4, the other one has to be 3. If it's 5, the other one has to be 2. If it's 6, the other one has to be 1. If it's 7, the other one has to be 0. And that's all you can go. And that counts to 1, 2, 3, 4, 5, 6, 7. So the answer is B, and Justin, you are correct. Good job. Um, again, hopefully this wasn't too hard, right? Because I mean, not sorry, not Justin, Jasper. Good job, Jasper. Um, again, hopefully this question wasn't too hard, right? Because again, it's a warm-up question, even though it says problem A, but in reality, all you do is count. So, if no one has any questions, we shall move on. Again, I'm sorry, not Justin, Jasper. Jasper, good job. All right, let's move on to the second question. Okay, the average of the 5 numbers in the list is 54. The average of the first two numbers is 48. What is the average of the last three numbers? Did anyone manage to solve this question? Just type yes in the chat if you managed to solve this question. Or go ahead and type the answer. Up to you. Okay. Zion, you have any thoughts? Zoom user, you have any thoughts? That's okay, Jasper. You'll learn right now. Um, okay, but it looks like that everyone is pretty much stuck. So let's go through this question. You know, it looks very abstract and it looks like they're not giving you any information. But in reality, all you have to do is set up an equation, right? So what we're gonna do is that we're going to let the 5 numbers be A, B, C, D, and E. Oh, okay, Justin's is 58. Let's confirm. Actually, in fact, Justin, would you like to share your thought process on this question? Tell us how you solved it. How did you get the answer 58? All right, that's okay. Okay. Again, the way you solve this question is you set up an equation, right? So you would do A plus B plus C plus D plus E. And you let these represent your five numbers. And so since the average is 54, that means over 5 is equal to 54. Agree? But in that case, that also tells you that A plus B plus C plus D plus E is equal to 220, right? Because if you multiply both sides of the first equation by 4, you would get that A plus B plus C plus D plus E equals 220. I mean, that's not 220, sorry, 270. Then, since it says that the average of the first two numbers is 48, you can derive the following, which is that A plus B over 2 is 48, right? Because the average of the first two numbers, A and B, is 48. So A plus B over 2 equals 48. And again, that means A plus B is 48 times 2, which is 96. In that case, if A plus B is equal to 96, actually, let me get a different color. If A plus B is equal to 96, and A plus B is equal to 96, and A plus B plus C plus D plus E is 270, that means that C plus D plus E must be equal to 270 minus 96, right? Does that make sense? Because in a way, you would be saying you have 96 plus this thing equals 270. So C plus D plus E is equal to 270 minus 96, which I believe is 174. And then finally, to solve the question, you'll divide both sides by 3 to end up with, what is this? 58. So the answer is indeed 58. So yes, Justin, your answer is correct, but hopefully your solution was also this, and not just a blind guess. Are there any questions about this problem? Any clarifying questions or any confusions? Oh, sorry. Okay, if there are no questions, let's move on to question 10. Um, Handy Aaron helped a neighbor 1.25 hours on Monday, 15 minutes on Tuesday, from 8:20 to 10:45 on Wednesday morning, and a half hour on Friday. He has paid $3 per hour. How much did he earn for the week? Did anyone solve this question? Bellas is 15. Okay, we have one vote on that. On the right, a tiny 1 for one vote. Zion says D. Okay, on the right, one vote here. Any other votes? Here, let's just do this. Type in the chat if you vote for A, if you think the answer is A. $8. 5, 4, 3, 2, 1. Okay. Raise your hand if you think the answer is B, $9. 5, 4, 3, 2, 1. Okay. Raise your hand if you think the answer is C, $10. 5, 4, 3, 2, 1. Okay. All right, D. Raise your hand if you think the answer is D, besides the people who already voted. 5, 4, 3, 2, 1. Okay. Raise your hand if you think the answer is E. Okay, we have another vote for D. Okay, so it looks like the general population is leaning towards D for this question. So let's find out. I mean, for this question, um, all you do is you find out the amount of time he worked and multiply that by his salary, right? Because um, if you look at the equation, what you're given is $3 per hour, right? You have three, you're given that Handy Aaron earns $3 for every 1 hour that he works. So that means if you can find out the number of hours he worked, the units will cancel and you'll end up with the number of money he earned, right? This is basic stoichiometry, and all you have to do here is find the number of hours he worked, right? And that's really easy because if you look at the question, it says that on Monday he worked for 1.25 hours, right? On Tuesday he worked 50 minutes. How many hours is 50 minutes? Well, there's 60 minutes in 1 hour, right? So one way you can do this is to convert all of the hours to minutes, which would be easier. You don't have to do as much fractions. So in this case, on Monday, he helped his neighbor for 60 plus 1/4 of an hour, which is 15 minutes. So that's 75 minutes on Monday, right? On Tuesday, he did it for 50 minutes. On Wednesday, he worked for 2 hours, 8:22, 10:20, and another 25 minutes. So that's 145 minutes. And finally, half an hour is 30 minutes. So that's total of 80 plus 155 plus, okay, that looks like a 300 to me. So in total, he worked 300 minutes, which is equal to 5 hours. Hopefully, we can all agree on that. And finally, he worked 5 hours, so that means he's getting paid a total of $15, which is not a lot for 1 week. Um, does this make sense to everyone? Are there any questions about this? Especially those who couldn't solve it. Are there any questions? Okay. All right. Let's look at the final question. The numbers -2, 4, 6, 9, and 12 are rearranged according to these rules. The largest isn't first, but it is in one of the first three places. The smallest isn't last, but it is in one of the last three places. Finally, the median isn't first or last. What is the average of the first and last numbers? Xeon votes C. Nice. We have one vote so far. Does anyone else have an answer? Great job, Xeon. Great job. Was no one else able to solve this question? All right. Well, hey, Xeon, would you care to share your thought process with us? How did you solve this question?
Um, so basically, if the smallest and the largest isn't the first and the last, then they would have to be like the second and the second to last. So then uh so then it would be 4 and 9. So if we add 4 and 9 together, it's 13 divided by 2, and that's where I got 6.5.
I absolutely agree. Just to flesh that out a bit, basically what Zion is saying that in the first statement it says the largest isn't first, right? But it's also in one of the first three places, so that means it's not in the last, right? So if you draw this number out, you have four digits, and you're curious about what these two digits are, right? You want to know the first and the last. And what the problem just told you is that the first and the last isn't going to be 12, right? It's not going to be 12 because it's not going to be the first and it's not going to be in the last, right? So it's not going to be 12. Now, if you look at the second statement, it says the smallest isn't last, but it's also in one of the last three places. So it's not in the first either. So that means you can cross out -2, right? It's not going to be in the first or last. It's going to be in one of the middle two spots. Finally, the median isn't first or last. Well, in this case, what is the median? Well, if you count -2, 4, 6, 9, 12, 6 is clearly the number in the middle. So that means 6 cannot be in the first or last place either. That means one of these numbers is 4 and the other is 9, either in the beginning or in the end in this order. So that means if you add these together and divide by 2, you get 13/2, which, as Zion said, is C. And that is absolutely correct. Great job, Zion. Great work. Are there any questions on this problem? No questions? All right. Let's look at the second set of questions. Um, I'm gonna give you guys roughly 10 minutes to look at these. And again, let me know if you have any questions. Don't sit there being stuck for 10 minutes. And we shall reconvene. Good luck. How are we doing? Are we almost done? Does anyone need any more time? Okay. Well, no one's saying that they need more time, so I'm assuming we're almost done. Whoa. Someone just typed in. Okay. Period is very passionate about number 13. Um, that's great. Let's look at number 12 first, and then we'll get to number 13, all right? Um, Nikki usually leaves her cell phone on. If her cell phone is on, but she is not actually using it, the battery will last for 24 hours. If she is using it constantly, the battery will last for only 3 hours. Since the last recharge, her phone has been on 9 hours, and during that time, she has used it for 60 minutes. If she doesn't talk anymore but leaves the phone on, how many more hours will the battery last? Okay, Zion says B. I see no one agreeing and no one disagreeing. So, um, does anyone else have an idea about how to solve this question? Great work, Zion. Justin says A. Okay, okay, all right. Does anyone care to share the thought process for this? How did you guys solve this question? How did you get 7? How did you get 8? Okay, someone says, I don't know. So I'm just gonna write that here real quick. Um, I don't know. F. Okay, so we got 2 votes for F. Nice. Okay, 3 votes for F. Great. Okay, let's take a look at this question. So the way you look at this is to use cell phone use in fractions. And what I mean by that is that if you look at the sentence saying, if her cell phone is on but she is not using it, the battery will last for 24 hours. So that means for every hour that the phone is on but she isn't using it, it uses up exactly 1/24th of the battery, right? And if she is using it, the battery is being used up 1/3 for every hour, right? Hopefully that makes sense, right? Because if she's not using it in the last 24 hours, that means every hour the battery is draining by 1/24th. And similarly, for every hour that she uses it, it's draining by 1/3. So it says that she has used it for a total of 1 hour, so 1/3 plus 8 hours in which she's not using it but it was on. So it's 8/24ths, which is another 1/3. So that's just 2/3. So that means there is exactly 1 minus 2/3, which is 1/3 of the battery left. So that means the answer is what? If she says that she just doesn't talk anymore on it, but leaves the phone on, so that means it's draining by 1/24ths every hour. So that means the answer is B. Yep. Are there any questions about this problem? No questions? All right. Let's look at number 13, which Mr. or Mrs. Period is very passionate about. Um, okay, so Amy, Bill, and Selene are friends with different ages. Exactly. Oh, I'm Leo. Nice to meet you, Leo. I mean, welcome back, Leo. Nice to meet you, period. Amy, Bill, and Celine are friends with different ages. Exactly one of the following statements is true. One, Bill is not the oldest. Sorry, Bill is the oldest. Number two, Amy is not the oldest. Number three, Celine is not the youngest. Rank the friends from the oldest to the youngest, A, B, C, D, and E. So, Leo, what was your thought process? You typed a lot of stuff. What did you think the answer was, or did you not have an answer, or did you think the problem was wrong, or what? Okay, will you guys explain what you think the typo is? Unmute and explain, because we don't have time for you to type it. Okay, Jasper says there isn't a typo. So Justin and Leo, would one of you care to explain what you think the typo is?
I
If
think
nobody responds, then
I think the typo is that from the oldest to the youngest. So I think it should be from the youngest to the oldest, so that E is correct.
Okay, so you're saying that the answer should be B, assuming it's
No, it's
youngest to
E.
oldest.
It should be E. It should be E.
Assuming it's youngest to oldest.
Yeah.
Okay. All right. I mean, it's interesting, but I feel like in general you shouldn't use your answer to change the question, right? I don't know. Let's see. Let's work through this question and maybe we'll see that Leo is right. But for now, let's work through the question and assume there is no typo. But maybe there is, but we'll find out. So, exactly one of the statements are true, right? So that means everything else is false. So again, it's not saying that exactly one of the statements is false. It's saying that exactly one of the statements is true, so everything else is false, right? So let's just assume that for now, number one is true, right? So this is the only true statement. Everything else is false. So that means Bill is the oldest, but that means that Amy is not the oldest is a false statement, right? So what that means is that no, actually the way I would put it is okay, so Bill is the oldest is the true statement, right? But that means Amy is not the oldest, right? Because if Bill is already the oldest here, Amy can only be the second one or the third one, right? She has to be one of the younger ones. So that means she is not the oldest, which makes this statement true. But, but, right? Again, it says that exactly one of the statements is true, right? Exactly. So that means number one cannot be a true statement, which means that maybe two and three is the true statement. So for now, let's assume that number two is the true statement. So Amy is not the oldest, right? So this is the true statement, and everything else is false. So Amy is not the oldest. So she's the second one, the third. So that means Bill is not the oldest, and Celine is not the youngest. So what does that mean? Right? Because if Amy is not the oldest, yeah, that's why you got to read these questions carefully, right? Because if it doesn't, you really trip it up. So Amy is not the oldest, right? So she's here or she's here. But then that means Celine is not the youngest is a false statement, right? So Celine is here. No, sorry. That means Celine is the youngest, right? Because it's a false statement. So Celine is here. But then it says that Bill is not the oldest, right? Because Bill is the oldest is a false statement. So Bill cannot be the oldest. So Bill is here or here. But then that's impossible because these two spots are already taken up, right? So two cannot be the oldest. Sorry, two cannot be a true statement. That might be kind of confusing. Does anyone need a, I guess, re-explanation on why two cannot be true? Okay, I'm assuming that made sense. In this case, we can assume for sure that 3 is a true statement and everything else is false, right? So this is the true statement, so that means Suling is the second is here or here. And then since Billy is the oldest is a false statement, that means he's in the second one or the third one. And finally, since Amy is not the oldest, is also a false statement. Amy is the oldest, in fact. And since Celine is not the youngest, is a true statement. Celine must then be in the middle. And finally, the last one is Bill. So that means the correct answer is ACB, which turns out to be E. Right, Jasper, that's right. Exactly one statement is true. But if you look at it, what we're saying is that we figured out first that number 3 is the true statement, right? But then if number 3 is the true statement, number 2 is a false statement. So what's the false statement of Amy is not the oldest? Well, that means Amy is the oldest, right? So we're using the false statement to derive the truth. Exactly. So the answer is E. And congratulations to anyone who got the answer E. So yeah, this question is a little confusing, but that's the AMC8. You gotta read carefully and think through it. Are there any questions about this problem? Nope. All right, let's move on to the last one. This one's actually pretty hard because if you don't know the specific theorem for it, you can't really solve it. But I'm curious, did anyone solve this question? What do you mean is the YMCA only math? The YMCA is the Young Men's Christian Association. That's where you do sports. What do you mean is it only math? You mean the AMC8? Is that what you're talking about? Because the YMCA is the Young Men's Christian Association. Okay. Well, let me know when you come up with the thing you're talking about. But did anyone solve this question? Response? Did no one solve this question? Are there any guesses at least? Any educated guesses about what the answer might be? Okay, Bella. All right. All right. Okay. You can't keep on picking answer choice F. I don't know, right? You have to pick one of the actual choices, but all right, for now, that's okay. All right, then I guess I'll spill the beans because it seems like no one solved this question. So for this question, ideally you would know the Pick's theorem or the shoeless theorem, right? And that's a theorem that says Pick's theorem. Let me type this. Pick's theorem. And I encourage you to look this up if you don't know about this, because it's a useful theorem. Basically, what this theorem does is that it allows you to determine the area of a geometric shape based on the number of lattice points in it. A lattice point is a point like this, like it's an integer coordinate, right? So a point like 2 comma 4 will be a lattice point, but a point like 2 comma 4.5 or 2 comma 3 halves will not be a lattice point. So again, Pick's theorem lets you determine the area based on the number of lattice points. And in particular, it allows you, the formula says that the area is equal to I plus b over 2 minus 1. where I is the number of lattice points in the shape and B is the number of points on the shape, the boundary. So in this case, if you count, you'll see that the number of lattice points inside a shape is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 21. And actually, is it 21? Just want to make sure. Yep, 21. And then the number of points on the boundary, which includes this one, this one, this one, this one, and this one is 5. So that means you plus 5 over 2 and minus 1. And that would give you 22.5, which is answer choice C. So ideally, you know this theorem, right? But now let's say that you don't know this theorem. Let's say you're taking the AMC 8 and you don't know this theorem. And so how would you solve this question without using that fancy theorem? And this is a great question to ask because like in a lot of questions, you wouldn't know the necessary theorem that gives you the direct solution. So you have to come up with something else. So does anyone have any ideas for how you might solve this question without using Pick's theorem? All right, really creative today. So the way I would do it is to calculate the total area of this square. Let me draw a better square. Hopefully, a lot of you already are catching on to what I'm saying based on what I just said. But can I draw a diamond? Nope, I can't. All right, I'm not gonna draw a diamond. So what I would do is I would calculate the area of the square outside, right? I would calculate the area of the square. Oh, this is really annoying. I'll calculate the area of the square, and then I would subtract the area of everything else inside it, right? So I would subtract the area of this region, of this region, and of this region. And that's really easy, right? Because the total area of the thing is a 10 by 10 square. So that's 10 times 10. And everything else is basically a right triangle, right? This one, area A, let's call it, has a leg of 4 and 5. So that means its area is 4 times 5 over 2, which is really easy. And this area B over here has legs of length 6 and 10. So that's 6 times 10 over 2, which is really easy. The last area is a little bit hard, but what you do is you make it into 2 triangles, right? You make it into 2 triangles like this, and now it's just a regular triangle, right? So for this one, it's called area C. You have a triangle of base 10 and height 6. So that's again 6 times 10 over 2. Really simple, really easy. And finally, area D, you have a triangle of length 5 with height, what is that, 3? So it's 5 times 3 over 2. And now if you evaluate that, you would get, what is that? 100 minus 10 minus 30 minus 30 minus 7.5, which is what? 60, 30 minus 7.5, which is 22.5, which is what we got earlier. Yep, so again, just proving to you that yes, knowing the proper theorems would be faster and more helpful. But if you don't know the theorems, it's not the end of the world, right? You can always solve it with a simpler method. You'll just have to be creative and search for something different and don't give up. But with that being said, are there any questions on this problem? If not, that is all we have for today. And thank you for coming and Merry Christmas. Bye.
Merry Christmas. Bye.
Great job, everyone.